So good afternoon and welcome to, what is it, since 1995. So 20, who does the math on that? We have been here, I've been here for 20 years. And 20 years is also the time we've encountered Dirk Bauerkämper at the Hannover Fair. That is my next guest here. Dirk Bauerkämper is Head of Market Management New Energy at Weidmüller Interface, and we'll be talking about the role of interface technology in the renewable energy market. Dirk, welcome.
Thank you so much.
First, a bit about the company. Weidmüller has a stand both here and in the other fair where you're really big.
Yeah.
We need an introduction to the company's size, location, and what you do broadly.
Yeah. Okay, well, at first I think we are not a manufacturer of electrolysis, neither H2 compressors, neither hydrogen refueling stations. But we are a company busy with industrial connectivity, and that is touching the electrotechnical installation as well as the automation and as well as the digitalization. So all what is necessary for the electrical installation and the electrical part of the electrolysis as well as compressors and refueling stations. And we are coming in here with 20 years experience in the wind power industry and as well in photovoltaics. And in so far, our company is really busy for years with renewable energies. And of course, the next logical step is to support the hydrogen economy because we have to really keep within this 1.5 degrees Celsius target, and we have to fight against climate change and global warming. In so far, our company is not quite new in renewable energies, but we are headquartered, by the way, in Detmold, which is in the middle between Hanover and Dortmund. We are working with around about 5,000 people worldwide and having manufacturing facilities not just in Germany, but as well in Asia and in the US, by the way. So what we are manufacturing is all kind of electronics, electrotechnical aspects, the communication devices, Ethernet-based routers, switches, and this kind of stuff, which is extremely necessary, of course, for the operation of all this equipment that is needed for hydrogen production and distribution.
Yeah, we'll have to get to that interface and its various interpretations. For me, it's interesting, just before we get to the core technology, it's a family-owned company. And I find this fascinating. Family-owned companies can have a vision as opposed to a CEO in a corporation who has to respond to a quarterly report. Is the company's obvious long-term involvement in renewable energy also related to the fact that they have their heart in the right place and they have this long-term vision?
Yes, of course. You know, the owner of our company is supporting this approach very strongly. And that is the same as the whole company is supporting this new energy, which, by the way, is consisting of renewable energies and hydrogen production with electrolysis, as well as post-processing like liquidation, for example, or like compressing or refueling. So it is our company's approach in total to support that and to fight against climatic change and to keep our world more green, I would say.
You just mentioned some technologies. A skeptic would say it's really hard to make a dollar in the fuel cell industry. You are actually providing technology specifically addressed at this market. What leads you to believe that these technologies, of course, long-term we know, that there will be a replacement of hydrocarbons with renewable energy. But in the medium and short term, do you have a specific reason for this? This is the first year you've been a member of our hydrogen fuel cell exhibit. Is there some trigger moment where the added dedication to this field became necessary?
Yeah, I think we experienced these trigger moments already last year, even though in Germany, with thunderstorms and with climatic change, what we can all feel. And that was I would say the latest triggering point for our company to expand our renewable energy activities towards hydrogen production and to reduce the CO2 emissions by using hydrogen for mobile applications as well as for industry. So it's definitely a need for our company to support that, even though we are a sub-supplier for companies producing electrolyzers or producing fuel cells, by the way.
So let's talk about the core technology. Often we look at components only. So I will have electrolyzer manufacturers on the stage or a proud owner of a fuel cell. But obviously they need a lot of infrastructure around them. And when you move up in scale, lost opportunities in not storing and analyzing data. I think of the classic case of the wind turbines and discovering that it actually is worthwhile to monitor all the information you can get from these things. It's free. And it'll tell you a lot about where to build future turbines, what the grid can do with this energy. So how does your interface technology optimize the capital investments in this field?
Yeah, well, I think the big headline, what we have in our company is digitalization, which is absolutely necessary to support the reduction of OPEX costs for H2 infrastructure plants. And what does that mean, by the way? That is touching condition monitoring, for example, which is extremely important to bring more transparency, for example, into an electrolyzer stack. Yeah. Right now we are busy with a single cell monitoring to really detect what's happening inside an electrolyzer stack. To pick up these data, to have some preconditioning of these data, to have a data communication, and at the end to use an AML tool, so automated machine learning, for some predictions of the degradation of, for example, a fuel cell or an electrolyzer. So the digitalization is a very important point, what we see, to reduce the OPEX costs for an H2 plant installation. That is, I think, the headline number one, what we have in our company and what we are strongly supporting with Ethernet-based products, with router technologies, but even though with data acquisition systems. And the second big line what we have is industrialization. And that is mostly consisting of modularization and standardization. I think that is clear when we're talking about an electrolyzer consisting of different stacks to modularize it and to repeat the installation. And what our approach is to combine also the electrical installation to these stack modules, for example, used in electrolyzer. To have an object-oriented approach and to use always, when we are scaling up, the same principles and the same technologies. That makes it easy in engineering, for example, that makes it easy in service. And in so far, we are supporting especially this aspect of modularization and standardization. Yeah? And especially standardization, that's also a good point. That is also touching the technical specifications we have to fulfill. Because H2 is an explosive gas. So we have to provide these mechanisms which are necessary, for example, to protect against hazardous areas, ATEX specifications, ATEX regulations, as well as security, integrity level, SIL components, for example. That is also some kind of a standardization, what we have to follow.
So standardization is, we all see this is super important. And by the way, this gets back to the metaphor of interface. There is a metaphorical thing. What I'm talking about is, do you remember those old printers and you had a printer cable, which are useless now, but you could look at it and say, that's a printer cable that fits into a printer. When you have a fuel cell or an electrolyzer, I don't know that there is a standard cable to plug into it to monitor what's going on. So at what level does this standardization talk? If you want to actually reap the data of electrolyzers, you do have to create a standard for all manufacturers in order to do that. Is that part of the standardization process you're working on?
Yeah, of course it is. You know, when it comes to, for example, alkaline electrolysis or PEM electrolysis or AEM electrolysis, the principle is quite old, but the data acquisition system, for example, detecting the single cell voltages as an example, this data acquisition system can be the same for all these different technologies. Yeah? It is just a question of picking up the voltages or the current densities inside a stack, and that is a standard which has to be established and which can be used for different kind of electrolysis. I think that is quite a good answer to your question.
Mm-hmm. Yeah, sure. So that's one level of standardization. You also mentioned operating costs. And my very concrete example would be, we all know that these wind turbines don't have an engineer next door running up and down the pole, figuring out what's going on. That's automation is really remote automation.
Yeah.
And the ideal case for a lot of these operating principles is you don't send someone to a facility. You don't need to have someone looking in a little glass window to figure out the temperatures. It is automated and related to the sensors installed and the standardization of those sensors. So for me, that is interesting because it is part of the operating costs that make this technology either a winner and a game changer or not. What challenges do you face when you talk about automating procedures like that with all these different manufacturers out there?
Yeah, well, one important topic, of course, is cybersecurity, for sure, because we have to protect against cyber attacks. So regarding our products, it's a question of being resistant against these cyber attacks. So we have to fulfill, for example, the standard requests, what we get from our customers or what we get from our authorities. I think that is what we have to fulfill. And of course, the second topic is to get access at every time to the installation, which may be quite far away from a monitoring center or from, for example, a control center. You know, we are also busy with the Aquaventus project, one of the quite well-known projects in Germany, and that is happening in the North Sea, about 100 kilometers away from Helgoland, so very, very far offshore. So this is also a question that technologies and electronics and router technology, the Ethernet communication should be available at any time, even though the distance and the environmental conditions are harsh, you know. So these are two challenges, and a third challenge is, of course, the ownership of data, you know. Who is really the owner of the data being generated? Is it the owner of the installation, or is it more or less the owner of the electrolyzer or the compressor? Yeah, that is also a challenge which we sometimes are facing.
That would be an interesting conversation to listen into, of course. This is all very current. Just recently, the software and communications for wind turbines in Germany was hacked. Luckily, when they don't operate, you're not losing the majority of the energy on the grid. But to the extent that this grid is going to be driven by renewables, that cybersecurity issue is certainly going to grow. Beyond that entertainment factor, it's filmed. It's ready for a James Bond movie. I'm sure at some point it's going to be made. You and Interface and James Bond trying to figure out who's hacking whom. But let's talk about the clients, because that really breaks it down. Like, who's interested in buying your technology? Who do you sell to? And how does that cooperation look?
Yeah. Yeah, well, we are a partner inside the supply chain, and our typical clients are, of course, electrolyzer manufacturers, as an example, fuel cell manufacturers, as well as, for example, hydrogen compressor manufacturing companies or refueling station manufacturers. These are our typical clients, which we want to serve with an entire basket for electrical connectivity, automation, and digitalization. That is, I would say, our client group number one, which we can serve quite well. And the second client group are the EPCs and the operators of these hybrid hydrogen stations, which we are serving with our software solutions, especially for optimization and balancing between the energy generation side and the energy consumer side. Yeah, you know, it's a question of your fluctuating energy coming into, for example, an electrolyzer, and then balancing the electrolyzer and the compressor and the tank and the refueling station in the right way. That is, it is at an operation point which is an optimal one. Yeah. So we have two client groups: the equipment manufacturers, which I named, and as well the EPCs and the operators of hybrid H2 stations.
This reminds me of a case in point, which is literally the engineer's dream is, in order to get the grid going for mobile applications, you would have a remote fueling station. It would have a solar cell on top, it would have a compressor built in, and it would have a typical tanking element at the other end, and you drive your car up. This is a lot better than trucking in the hydrogen if you don't have a pipeline. Yeah. And of course, the last thing they thought about is the monitoring. So they hadn't solved that one yet. That's a fundamental thing, of course, because you have a capital expense there, and all of a sudden, if something goes wrong, who's there to fix it? Or could you fix it by simply monitoring it, I suppose?
Well, it is more than monitoring, of course. You know, it's a question of SCADA systems. So there has to be a bidirectional operation between the consumer side and the electricity generation side. So what we have to do is, and that is also what our components are providing with some intelligent controller solutions, to have an interface between the different controller parts being installed, for example, at an electrolyzer or at the compressor. So there has to be a bidirectional interface that we can really balance the operation of the different equipments in these hybrid hydrogen stations.
You mentioned when we were preparing for this talk an expression that I have not encountered in all my years here. In the fuel cell industry, this may be a comment on how small things have been until very recently. You were talking about electrical procurement companies and just referring to them as EPCs as part of your clients here. Yeah. Now, this is common knowledge in your field who electrical procurement companies are, but they're among your clients. Can you describe what exactly that involves?
Yeah, well, that involves mostly at first Ethernet infrastructure, which is necessary and which is of high interest for them, but as well, for example, nice software solutions to connect the different equipment which you will find in an installation. And of course, they would like to have concepts which are easy to install, so not so cost intensive. And then we are coming back, of course, to modularization and to connecting the different equipments necessary for the operation in a very fast way. You know, these are some aspects which are quite interesting for the EPCs as our clients.
So. We've almost run out of time here, but I can't resist a final question. Those of you coming from North America, notice it while you're here. There's no brownouts and blackouts. The electrical grid is very stable, very reliable. That is, there's a pile of monitoring software, all sorts of things happening in the background, remote observance of what's going on, and it works. We have to do this for the future hydrogen and renewable energy grid. And here the very simple question is, how far away are we from having the necessary interface technology that allows for a stable grid running on renewables?
Yeah, well, of course, it depends a little bit on the size of the installation, you know. If we are talking about the local installation, where you have some wind turbine or maybe a PV installation and an electrolyzer and the refueling stations, locally, I think we are quite on a good way to solve that. But if it comes to the huge installation, maybe in a region like North Rhine-Westphalia in Germany or north of Germany, I think we are some good steps away from this, control and observation of this installation. And especially if it comes to cybersecurity, what we talked about, there are a lot of challenges. So I think we just started to make it safe and reliable to be used on a global or on a regional scale, I would say.
Okay. With that, I'd like to remind you that you can address further questions to Dirk Bauerkämper from Weidmüller Interface. The booth is, if I'm correct, right down this aisle.
There is D44.
D44, and you're also in Hall 11 with your big exhibit there.
Yeah, exactly. And quite a good recommendation for you. Industrialization, for example, as a topic also very important for hydrogen, can be discovered on our main booth in Hall 11 because a lot of machines showing what is possible for electrical connectivity, for handling of wires in a most modern way and highly automated. So just a recommendation.
Okay, so yeah, visit both of them. Thank you very much, Dirk, for being here this week. Welcome to the first appearance in our exhibit. Hope to see you back next year.
Yes, thank you so much, Brian.
Thank you.